All right, amazing hacker. Let's go on to the CSRF part of this course, shall we? So again, the same credentials go. Just go to the FTP server on hackspert.com. Use training as username. Use test as your password. I use FileZilla as my FTP client, and you are going to create a file on there. And it's gonna be a file like this with this content. And with this file, just upload it onto your server, and that's going to be the first thing we're going to look at. Is we're going to send some money to mom, for example. Let's say $1 off to mom. You have sent $1 to mom. Okay, mom is very grateful for us to us for this. But then let's open up CSRF proof of concept generators, shall we? Because now we're gonna look at the scary part. This was hosted on security.love is the website /CSRF proof of concept generator. We have the URL that we want to generate our proof of concept for, and the values can be found if we look at the response at the request. So we can do that very easily. Just go to your network tab, have it open, then you're gonna see a bunch of things pop up here. I always like to look at XHR in specific if you want to. Now for this case, we're gonna look at our PHP request that we see here. And in here, we're gonna see a request with a payload amount 1 with recipient mom. So let's copy these fields over, and let's copy these values over as well. But you saw already that these were separated by the ampersand sign, so we shall put it in here as well. And the values were with the equals, not with the double point. So let's send $1,000 off to attacker. This will be our account and will generate this proof of concept. Now we have an HTML file here. We can host that on any computer that we want. Right now I'm opening it locally, so for my own computer as a web server. And if I click it, bam, you see that I've sent $1,000 off to attacker. And you might be wondering, okay, Uncle Red, what's so strange about this? Because I know who I'm sending it off to. It's written right here. But if I am a really crafty attacker, I can just hide this field and say recipient equals mom and put a fake field there, a dummy field, and it'll show sending $1,000 off to mom. But in the background, the real recipient will be attacker. And then I have a CSRF vulnerability on my hand. So the attacker can actually, from their own website, if the victim is logged in and they click on the attacker's website, then they might be sending money off to an account that you didn't intend it to go off to. So that's a bad vulnerability, of course. We're going to add some security to that, because oftentimes we'll generate a CSRF token, as you can see right here. So we'll set that CSRF token. Sorry, if it's not set, we'll basically generate one. The way we do that is by generating 32 random bytes and then converting that binary to hexadecimal. So that's why every CSRF token looks like that. It's a hexadecimal converted from binary, that's 32 bits. Usually that's how it's generated, and then of course that's bound to your session, and then we have to put that in the form still somewhere in an input field, in a hidden input field preferably, because this is hidden stuff. The user doesn't have any business with this. This is just backend stuff going on in the backend. Then we get this particular URL here, but if I pop that in the, so again, upload that file onto the FTP server, and then go there, navigate there, you will get a URL like you will right now. Just like this is the base URL, hackspert.com/training, and your file name will go behind that. And just like before, we have the same thing, only now our URL is a little bit different, but this proof of concept will still work. And that's because we have added that CSRF token to the form. It is there, it's not missing. We'll inspect the source code just to confirm this. As you can see already right here, the value is there, but it's never checked by the server. So that's the last check that we'll need to add, and I have that prepared for you as well, of course. We can set a new check in here. There we go. So we can say you have sent amount of 2. So here is where the logic will go normally. And we are using the hash equals function, not loose type comparison. We're literally using the hash equals function. And then we're saying, do your logic, and if your hashes don't compare, so the one in your session versus the one that you have in your form right here, if those are not the same, then deny that transmission and say transaction, I mean, of course, and say CSRF token error. Now, if we look at that code wise, we can see that I have the same thing right here. Again, my URL will be different, but this time proof of concept will no longer be working. You can see right here, CSRF token error. And that's because we've added that final check in right now. Of course, you don't want to have that session or that token be generated on every page. You just want to have it generated in one particular location, so that if you have to do maintenance on it, you can easily do that. And you don't have to duplicate any code. Again, we're using the hash comparator functions here, because the normal comparators, they might open us to type mismatching attacks. And we can always use one central CSRF generator and validator and include that on all of the pages. Check the full parameter and not just part of it, of course. What I mean by that is check the full CSRF token and check if it's fully valid, and don't just check the first 6 characters of it. You might be laughing at me right now and saying, why would I only check the first 6 characters of it? I have no idea, but that actually occurred in a program that I was hunting on. So thank you very much for listening. See you in the next chapter.